You don't want to see that. That's not interesting. Well, you do want to see that, but not right now. There. All right, I'm late. How much snow? You thinking about moving to Denver? Ice? Are you going to move to Denver? Okay, good. We get tons. No. We don't get much, actually. Denver is really a high desert. So most of the snow falls in the mountains because it comes west to east and it comes across and moisture drops. And so we don't get a lot. So if you talk about precipitation, I think we're about 60, 70 inches a year in Denver. I know this is not what you came to see, but it's, he asked the question. Just like Seattle, right? You don't really get a ton of precipitation, right? You get a lot of mist and drizzle throughout the year, but not a lot of inches. It's the same thing in Denver. We don't get a lot of inches of snow and precipitation. But oh, look, there's light from Brazil. Like, you don't have to smoke up here, right? You can just come inside. All right. It's Brazilian guys. Got to watch out for them. All right. I think I'm ready to go. Everything's on. Everybody, you're here to talk about encryption, right? Yeah. All right. Good. Good. Welcome. Thank you for coming to SQL in the City. Hopefully you're having a good day, learning something, enjoying this. Please fill out your evaluations at the end of the day. There's wonderful, amazing prizes that you'll win. But also, we would love to know what you like and don't like about this format so we can decide if we do it again next year. Come back here. Don't come back here if you don't want us to come. Tell us to come somewhere else. Let us know what works and doesn't work. I am Steve Jones. I just want to make sure. And I run SQLServerCentral.com. I started that site a little over a decade ago, and I've been running it ever since. About 5 years ago, Redgate bought my company, and so I work for Redgate now, and that's why I get to come here. And I don't wear the red shirts, though. Not like that guy. So if you have any real Redgate questions, ask that guy back there. And if you better know the answers, every one of them. Tell your boss. So we're going to talk about encryption today, different things. I'm not going to read the slide. You're big. You can do that. If you can't read the slides, you already told me you could read them, so I don't want to hear anything anymore. All right. Anybody know what that is? It's the Enigma machine from World War II. It's one of the first really, really complex encryption things where they would stick these wheels in here, and as they typed, it would do the encryption, and the order in which these were set would determine what the actual key was, kind of. And so if you didn't know where to start those keys, you couldn't decrypt and encrypt it. Very cool system. It's actually a great movie about that, 39 Steps, I think it is. Really cool. Encryption is the process of essentially transforming what you can read to something you can't read. It's almost like randomizing what's there. There's a kind of a formal definition, but we're essentially taking our plain text, the stuff that we have, and we're trying to make it unreadable into ciphertext. Now, obviously, we have to have a way to get that back because if we encrypt it and we can't read it, it's no good unless we can get it back. So the process of taking the plain text to encrypted text is the encryption, and decryption is the process of coming back to something we can read. All right? Quick example, a very simple cipher. This was the Caesar cipher. Probably a lot of you guys did this in 3rd and 4th grade as kids, where you would do the substitution of letters. Trivial, easy to break. Essentially, you got 26 chances to figure out what it is. Not that hard to do. More complex encryption is something like Symmetric Key here, and we'll look at this a little bit later in SQL Server. They give us all these options for doing encryption. Let's first, though, talk a little bit about what we can encrypt and where we can encrypt things in SQL Server. And so if I've got this kind of set up where I have my SQL Server, I have the chain over to the client and that kind of thing, I can't encrypt anything in the client file system. Drop a file there, I'm done. Because I have to give them the key to decrypt it. And if they have control of that key and it's on the file system, we're done. So it's really important you understand you can't encrypt anything there. Can't encrypt anything on the screen, really, or in memory there, because that's the same thing. I've got to physically send that stuff across there, and once they have the data and the key, we're done. Interestingly enough, a quick story. Years ago, anybody remember Pentium processors? Anybody ever use a Pentium processor? So when Intel was building these back in the early 90s, they set up a system whereby they would not download anything past this point. And so all the designs for their chips were only sent as the screen picture from essentially what would have been, we know, as like a Citrix or an RDP session over here. So they never downloaded anything to try to protect this side of their design. They had engineers working at home. Engineer actually broke this by taking a Polaroid camera and taking a picture of the screen, pulling up all the chip designs, and actually sold some of that stuff to AMD. So I can't handle the encryption there. Obviously, once they can see it, we're in trouble. I can, however, encrypt this communication link. We have ways in SQL Server to make sure that I have a secure communication link to the client. I can encrypt data in memory. I can encrypt data in my files, and I can encrypt my backups, of course. All right? So when we talk about encryption, we're really talking about the SQL Server side of things. Anytime it gets to the client, be aware, not really protected. Now, some of you, anybody in HIPAA or PCI, that kind of thing? You guys have to do encryption. You have to worry about this stuff. You really don't. You kind of got to just say you're doing it. It's not really matter. If you say you're encrypting stuff here, it'll usually pass those audits. Kind of the imperative of encryption. Sorry to say, it's just the way the world works. Complain to your congressman if you don't like that, or senator, or whatever. Our hierarchy here is inside of SQL Server. This is from Books Online, and when you get the deck, there's a link so you can go look at it. I know it's hard to read here, but essentially, everything in SQL Server, this is kind of upside down. The protection starts at the Windows operating system. The DP API, Data Protection API, is what encrypts everything else. SQL Server builds on that. It's been proven to be very, very strong. Haven't seen any known exploits in the wild that say people are breaking through DP API in Windows. So if you're a Unix guy or Mac guy and you're upset, sorry, Windows does this really, really well. And then we have various keys and things that will go through SQL Server. I'm not going to go through this in detail. All right, basics of encryption. Now let's get into a little more details. Anybody use transparent data encryption here, TDE? Okay. It's a cool system. It was introduced in 2008, and it was designed to be transparent. I can encrypt my databases, and I don't have to change my application, no developer time, nothing. Everything works well. What this really does, though, is it only provides limited protection to my system by protecting the data at rest. So SQL Server still sees all the data as unencrypted, as normal. It works fine. Any clients that access the system, they can access it. So I'm really only protecting the files on disk. Very limited protection. And the backups, of course, too. But it's a very limited protection. Essentially, anytime something comes out of SQL Server, a read or a write, it goes to an encryption layer, and then it hits the disk. All right, but all our clients, everything else sees this as unencrypted. The transaction log is encrypted. Make changes to data. Can't have people reading a transaction log. It's almost as good as reading the data. So there's overhead here that the transaction log is also encrypted as well as data. So anytime I have to do lots of writes, if I do imports, that kind of thing, lots of changes, I've got to do the encryption process in the transaction log as well. My backups are encrypted because if I encrypt the database and then I don't encrypt the backups, not solving a lot of problems there. The backups are encrypted. TempDB is encrypted for everything. So every thing on your database, on your instance that uses TempDB has to go through encryption now. So if I've got one database that I've got to apply HIPAA controls to and it's got to be encrypted, and I have 45 other databases on there, any of those queries that hit TempDB have to go through the overhead of encrypting and decrypting data in TempDB. Not a lot of overhead, but be aware that it is there. Replication does not matter. Right? Can't send encrypted data to another side, well, because it doesn't help, right? I mean, the other side's got to be able to just read the data anyways. So you've got to be aware, if you send replication data out, it's not encrypted. It's a hole, potentially. File stream, file table data as well is not encrypted. There's limitations. This is actually very easy to turn on. We really just run this command. Now, there's a little bit of setup ahead of there, but this is essentially how you turn encryption on or off. We have to create a few keys here. We've got this DEK, database encryption key. This is what controls access to that database, and it allows the decryption to occur, and the encryption as well. If you lose this key, do not call Microsoft. They're not going to help you. Encryption is serious business. If you lose that key, you're not decrypting anything, unless you want to go spend a few $1,000s on Amazon and just brute force your database, because there's just no way around it. Encryption is serious business. You lose the keys, you lose the data. There's no recovery secret mechanism from Microsoft. CSS will take you $300 and say, sorry, good luck. Find another job. Make sure your resume's up to date. If you lose this key, by the way, be aware. This key is protected by a key in a database. We have a database encryption, or database master key, which kind of protects the instance, and we'll have a service master key as well, which we'll talk about. You've got to make sure you back this thing up. Please don't back it up in the exact same spot as your database backup. All right? There should be a password on it. It provides limited protection, but one of the tenets of encryption is you want to make sure you keep your keys and your encrypted data separate where possible. If somebody gets control of both of them, they have a much easier time of accessing your data. Some people will back it up anyway on there. be aware, you better have a really, really strong password on that key. So something long, not like P@SSWRD. That's not a good password. Be aware. All right. Essentially how this works, this is a diagram from books online, but it kind of just goes through the encryption level where we've got Windows and the system key and then the database master key and then your certificate. And I'm not going to go through it all because it's really not, it doesn't matter. It's a technical thing and you can't change it or do anything. It's just the way it is. I have friends that run this on some large database, and a couple of you that run it may say they see the overhead is really less than about 5% on their large systems. So it's not a lot of overhead to do this encryption and decryption piece. You decide. It is enterprise edition only. So don't ask me if there's some trick. If you don't have enterprise edition, you're not encrypting it. All right. Is it worth it? Is it worth it?
Yeah. To be HIPAA compliant, it's got to be encrypted at rest.
That's the thing, right? Is this really valuable? Does this really protect your system? There's some debate and argument about how extensively this protects things, because if you lose physical control of your files and your disks and things, it's hard to tell if it's really important. But it's a checkbox. If you're a HIPAA person, if you're a SOX person, if you have regulatory requirements, this is a checkbox that will get you out of a lot of other stuff. Auditors will just leave you alone. All right? Whether it's worth it or not is up to you. There are third-party tools. Redgate, we make storage compress, and we provide encryption for your data files as well with storage compress, and we use AES algorithms and all that fancy stuff as well. So there are other options as well besides TD, but whether or not this is valuable to you, I don't know. From a security standpoint, if you're actually looking at true security, trying to provide protection, it's a little bit debatable, but if you're trying to just get past an audit, works great. All right, any questions? Yes, sir.
Log shipping?
Log shipping. So if you're going to do log shipping, you have to have that certificate moved to the other side to do the restore to read the backup. Okay? Yes?
Data dictionary and SQL jobs.
If data?
Data dictionary, master and MSDB databases.
I don't believe master. Can master be encrypted? I don't think so. That's a good question. I'll have to check. I don't think master can be because I don't know if there's a mechanism to open that up prior to the instance starting. That's a really good question. Remind me of that later, please. Okay.
I have one more.
Okay. It's not going to be hard, though, right? Because I already messed up. All right. I don't want to mess up twice.
Restore to non-prod environment.
Got to have the key. You either got to have the key, or you better have a really good resume. It's up to you. Pick one. Okay. But if you don't have that key, you're not restoring.
So even within the same domain, you
Still
still need a key to
need a key. Okay. Don't call Microsoft. All right. Got to have the key. Yes.
If you don't have the key, but you do have the password that's it's created with, will that same password create the same key? Or
No.
different?
Nope. Nope. Mechanism used to create the keys in this particular instance will not recreate that key. Okay. So seriously, before you encrypt the database, you create the certificate and the key, back up the key first, then encrypt the database. Because if you forget the password, out of luck. Don't call me. Don't call Microsoft.
Can it be stored in keypads?
Can I restore?
Can it be stored in keypads?
I don't think so. It's a binary file. I don't know if all the characters are in the visible spectrum that can go into KeyPass. Because KeyPass works, you can store the password, but the key itself I don't think would work in KeyPass. You can store it in version control. I mean, there's other mechanisms that could do it, but you need to protect it. Okay? And you got to have it for restores, by the way. So got to have a copy off-site. Don't leave it on the server. Right? Server goes bye-bye, key goes bye-bye, and then what? You need a job, right? You get your resume, Nate. You got your resume done, because I'm telling you. Lose that key, you're done. All right, let's go to hashing. So hashing is a very common type of algorithm in computer science. We use this all kinds of times. If those of you are old like me probably wrote sort routines when you were young, bubble sort, quick sort, hash sort. We use hash buckets all the time to essentially take data and reduce it to some representation that we can then use to bucket things. So what we do in the phone book is we bucket everything by the first letter of your last name, right? That's essentially we hash you down to this section of the phone book is A's, this is B's, this is C's, D's. You guys with me? E's. All right, you get it? I don't have to keep going, right? All right. Come on, wake up. I know it's after lunch. So here's the definition of hashing. Essentially, that's what it's doing, is you're taking some data, you're reducing it through some algorithm or function to a smaller representation that's easier to deal with. So we do this a lot in memory. If you do partitioning, you're essentially doing hashing. Okay? It's not a very hard concept. SQL Server, we have the hash bytes function that essentially does hashing. The checksum and binary checksum as well do a hashing type mechanism. There's other implementations. There's all kinds of algorithms out there. This book by Michael Coles is a great book to look at. It gives you different ways you can do this in CLR. They're useful in just computing in general, but in terms of encryption and security, it's pseudo encryption. It's not really encryption, but we'll talk about it because it comes up in encryption a lot of times. SQL Server 2012 adds a couple of algorithms here. Prior to 2012, we had SHA 1 and 2 in 2008. Those are not seen as providing strong enough encryption these days due to the complexity and speed of computing machinery these days. SHA and SHA 2 are not seen as viable algorithms. Just be aware. All right? You can use hashing to mask data. You guys probably all see, you go to Amazon and they show you, star, 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 and last 4 digits your credit card number. They're essentially hashing out pieces of this. They probably hash those 4 digits out to something else when they store it in the database, and they use that for searching. Hashing works really well because it's deterministic. If I run the same code through the same algorithm, I get the same results. So that allows me to do some neat things, because I can index it, because I know I'm getting the same thing. If I go through a lot of encryption algorithms, I don't get the same thing every time. Right? Good for security, bad for searching. So in hashing, we'll do that. So let's look at a quick demo of hashing. 1, 2. I don't know why it does it 3 times every time. It's amazing. I bought this off the Big Bang Theory, actually. No, I'm kidding. Oh, that was bad. All right. I guess you guys want to see this code, right? Do you want to crowd up around my laptop? No?
That's dark encryption.
It's dark encryption, yeah. It's a visual spectrum encryption. Hold on. This thing is going to fail. I have a right-handed laptop and a left-handed user, so that's the problem. All right, hashing. So real quick, hash bytes. I just got a string. I'm going to pass it through hash bytes. I get this. You guys know what this says, right? It doesn't say anything. It doesn't matter. But if I run that same string through there, I'll get the same thing every time. Let's hash. Here, I'm just going to take a couple of strings, and I'm going to hash it with a couple of algorithms. So hash bytes allows me to choose an algorithm. I'm just going to put all these together so we can just kind of see some differences here. That's not what we want to do, though. We want to do this. And so here, string 1 and string 2, like thing in 1 and thing 2, same concept. SHA, SHA1, these are really the same thing. I don't know why SQL implemented these together, but these are the same algorithm. SHA2, you can see it changes things around. Or sorry, 256 and 2512 change things around, so I get a different result. The algorithm matters. I can't just shoot things through a hash and assume they're going to come out the same. The algorithm will actually change what results there are. So how can we use this? Yes. Who?
What's the chances of getting collisions when you do that?
It can be pretty good, actually.
So there's that. I had a little bit of experience with that, and I've run into collisions. But I mean, how long do you have to go before you? There's no collisions. I mean, doesn't that break the algorithm?
Do collisions break the algorithm? Yeah, yes and no. Sometimes you want things to hash down to the same values. I mean, there's value in that happening. For example, if you're trying to figure out how I do sorts or put things into memory, sometimes you want things to group together, and so there's valid reasons for collisions. You have to be really careful with this. A lot of times you might use hashing for something like I'm doing a large ETL import, and so I use hashing to tell if something has changed. I'll hash a row and I'll say is this, and I'll hash another row and I'll go, is it different? Now I need to do work. A lot of times it doesn't matter if you have those collisions because it's just a little extra work. It's not a big deal. In terms of security, it can be a problem because it means if you've got a path, if I hash a password, somebody else they don't need to know my password. They just need to have a way to produce that same hash. So I'll talk about that a little bit in a minute, but it's good and bad. There's not a lot you can do around it. One of the things you can do, though, here is add what's called a salt. So if I have my string, I'm going to create a salt here. And essentially, what I'm going to do is I'm going to concatenate those together. And so I provide a difference by taking an unsalted string and a salted string. You see I get something different. So how do I use this? Well, let's create a little database and a little table. Okay? Nothing magic. I'm going to put 2 users in a table. Probably all of you have something similar like this somewhere in your application where you have a table with users and passwords. People log in, authenticate, right? You don't store your passwords in plain text, right? Nobody? You better not, all right? I'm telling you, you're asking for trouble. Please don't ever store your passwords in plain text. In this case, I haven't done it. I'm going to create a little store procedure. All this is going to do is compare the parameter with the value in the table to see if it matches, okay? And so if you can see here, I'm just going to pass in my name and my password to this, and I'm going to get a result, all right? There. I knew something was going to happen. It just tells me it matches. So all it's done, if I go back up here just slightly, you'll notice when I inserted this data, I took my password, which is an example of a better password other than blank or password or something dumb, and I run it through hash bytes here to give me semi-encrypted. I hate to use encrypted, but it's kind of hidden. And all I'm doing here is I'm running the parameter through hash bytes again, same algorithm to compare with the username. Everybody understand? All right. Anybody embarrassed because they don't understand? Nobody's going to admit that, are they? That's fine. All right. All right. So I'll try a different password here. You can see these are different. If you don't believe me, I'll give you the code. You can test it yourself. Fails. Right? Normal, what we expect every day. Application developers then make that look really good. They go, you know, sorry, we can't find your username or password. Click here. All that stuff. So now I'm going to do an update. I'm going to actually, Andy, my partner, Andy Warren, is kind of mischievous. He takes his password, hash, copies it to my row. Okay? Doesn't know what my password is. He just copies it over. So now what happens? Well, he goes to log in with his password and my name, and it works. He's attacked my password application without knowing my password. This is why you worry about SQL injection. Somebody will do something like this, either copy a password over, or they'll inject a known hash for which they have the original value into your table. Now, if you don't use hashing and you just store the plain text password, you make it much easier for them. And I'm sure they greatly thank you for all those efforts. But this is the way that people attack you. Yes, sir? Can I encrypt the hash? Sure, I could. I mean, I could do any number of things. But, you know, I use hashing because hashing is fast. Fast. Encryption is not fast. If I go to log in, this fails. Okay? What can I do? Well, let me fix my table first, because otherwise nothing else works. All right, so I'm going to fix these. I'm back to my original hashes. If you don't believe me, well, whatever. I can't prove it to you. I'm going to alter my procedure now slightly. And what I'm going to do now is I'm not going to just hash the password. I'm going to hash the password plus my username. Okay? So now, if we check me, it works. I'm going to do my same little hack. Andy's going to copy his password over. So he's going to log in, and it's going to fail. Because he can't pass in my name for my permissions with his password, even though he's hacked it, because I'm concatenating these two together. So now the attack doesn't work. Now, I don't recommend, for the sake of argument, I just showed you the username. If you pick another field in the table, you're not providing a lot of security, because how many fields do you have in your table? Hackers are patient people. They will just try them all. But you could do the username plus some scalar value plus a password, or some combination of things that make it much more difficult to kind of go against hashing.
Are you broken at this point?
Am I broken? Absolutely, I'm broken. Oh, let's go back to me. I'm somewhere up here. Nope, here. Nope, that's new password. Old password. I am broken. Okay? But that's a trigger. If somebody changes the administrator password, Administrator's got to know it was changed. You can't have him change it back. He's got no way to change this back necessarily. I guess he could test, save it, put it back. There's different ways you could do that. But that's a good trigger to know. That's why users, especially administrators, ever find something weird, like your password appears to be changed, doesn't work, got to raise a flag. Got to be worried about security then, somebody hacking you, doing something. Okay. So another reason in Windows why you can take ownership, can't give ownership. Can't take ownership, change files, and give them back to somebody. All right. There's a reason for that. This is the reason. Security thing. That make sense? Everybody awake? Everybody bored? Come on. I know he's paying attention. Nobody else, though. All right. Let me drop these because next time I do this next week, it'll fail. Let me look at checksum. Checksum works similar to hashing. It's a variation of hashing. You guys probably all use checksums. We see them all the time where you essentially run some series of data through there, you get a value, and then if you run it through again later, if you get a different value, you know something changed. Application developers do this all the time. It's an easy way to check what's happening. Sometimes if you send a row down for editing to a client, you run a checksum on it, and then when they hit save, you run the checksum again. And if they're the same, you don't save it because they didn't make any changes. Right? But if they did make a change, you can send it back. So how useful is that? Well, you asked about collisions. Let's look here. I've got two values here that I run through. They checksum the same value. Okay? Is that good or bad? Depends on what you're using it for. But when you go to checksum, hashing has some collisions, not bad. Checksum has tons of collisions. Really hard to use this. Even in application, because you might end up doing lots of work you don't need to do if you've got large sets of data you're running this on, because you get all kinds of collisions. Binary checksum is no bad. Here I've got three values. No better. All of these come to the same value. And if you just go through and play with different sets of values, you get tons of collisions in here. So if you want to use checksumming of some sort, I would use a different algorithm. I would use CLR and build a different algorithm. Just go research computer science, checksum, and you'll find other algorithms. These are not great. Lots of collisions here, okay? All right, good there. Questions? Yes?
This is a little bit off topic, but does this...
They don't mind, really. If you want to talk about Colorado again?
Yeah.
All right.
The collisions, do they affect your decision whether you're going to use torn pages or checksum for when you're monitoring corrupted pages?
Okay, so that's way off topic, but torn page detection from SQL Server 2000 and checksum in SQL Server 2005 and over are different. And the reason is checksum is at every page level. The torn page detection is a more gross thing where it's only checking, I think, every 4 pages. Here's an MCM. Where's Gail? I think it's every... Huh?
You're basically dividing the page into, each page is a bit, or each 512 bytes on your 8K page has a bit. And when you're writing each of those sectors to disk or those sections,
Yeah,
it's flipping the bit.
it's flipping the bit. So it detects less errors. Okay, so use checksum. All right.
That was my
Fair
question.
enough. That's not this checksum. That's different. That's a different checksum. So there's checksum on pages, there's checksum in backups, and there's checksum function here, all separate. Okay, but they all do a similar thing where they run a set of data through an algorithm and come up with a number, and then they use that to determine if changes occurred. So when you do backup with checksum, what it is doing is it's calculating a checksum on a page right in the backup file. When you restore, it reads, calculates the checksum again, compares it to what's there, and it can tell you if your backup file was changed and you have problems. Okay? Essentially, the pages do that as you read and write pages on disk as well in your data file. This is more an application programming, but same process. All right? Good? All right. Not really encryption. Just not. Most of these hashes are one-way hashes. There's no good way to come back. But as we see from collisions, multiple values can come back to the same, can hash to the same value. If you've ever heard of rainbow tables, they're essentially have taken all these different words, phrases, and things, and they run the hashes on them, and then they have this table of values. We're SQL people, right? We like tables. If I find out what the hash is for your system, I don't need the original value. I can just look up in a rainbow table an equivalent hash that equals, and just grab that password. Doesn't matter if it matches yours. You got to be careful. There's value in doing this. It works very fast. You just have to be careful of it. Hashing is really quick. All the other symmetric and asymmetric key stuff is slow compared to hashing. Just like memory is fast compared to disk, right? This is fast compared to the other algorithms. So there's advantages to doing this. You can hash this stuff. If it's said here, people will hash a portion of their encrypted data, use that for searches because you can index it. It's deterministic. Works really well. Encrypted data, can't really index it. And then obviously choose the strongest algorithm that you can if you're going to hash. This is not, SHE1 is not a viable algorithm. Just not. Okay. So, all right. Whew. Tired. I'm done. Somebody else want to finish? No? All right. Keys. So we have all these different keys in SQL Server, and it gets a little bit confusing sometimes, but they're different level. This kind of goes through the way that we would use them. We have a service master key, which protects our instance, and is an instance level key. Without this key, your instance does not start. All right. So again, if you start to enable encryption, back up that key. Database key does for databases. Then you have various encryption keys below that, and we'll talk a little bit about these. Here's a hierarchy in pictures, if you like pictures better, but I'm not going to spend a lot of time there. So the service master key, this protects your instance. There's different documentation that says it's created when it's first used. Some say it's created when you install SQL Server. Ultimately, it just doesn't matter because if you're not using encryption, you don't care. And when it's created, it doesn't matter, right? You can't create it. You don't do anything about it. You can back it up, though. All right, and you got to make sure you back this up. If you enable any of the encryption features that will trigger this, create a database master key, a database encryption key, better make sure you back this up. Because without this, you can't do your DR, you can't restore, can't start SQL Server. It's secured by the Windows, and it's essentially locked down to the service account that runs SQL Server. You can set a password on this and break that link if you want, which means you'd have to enter the password before SQL Server would start, but you have that there. If you change this, you have to have a new principal that you can assign it to. All right? So you can't. I don't think you can do this with local service. You've got to have a different account in place. Back it up is normal DDL. All this stuff's recorded through all the DDL we expect. There's no create here. There's just backup and there's restore. In a DR situation, you have to have this key because you just can't restore the master. You can't restore anything else. So it is important. And again, if you don't have the key, don't call Microsoft. You can regenerate this. There's a command to actually just regenerate a new key. What this actually does is it will decrypt every key above it. So all the database keys that are there, it will decrypt all those to make sure that they can be decrypted. Then it will re-encrypt them with the new key it generates. Resource intensive, a little time consuming. You can force it, though, to skip something. Why would you do that? You may not have all the database keys protected here, or you may not care. You may have added a database from some other server that has encryption. And so there are reasons why you might want to force the service master key to regenerate and not care if it can't decrypt every database master key. But just be aware, if you don't know how to get to that database master key, you don't have a password for it, and you do force this, data loss, gone. No, do not pass code, do not collect $200, do not call Microsoft. Use AES algorithm, which is a well-known encryption algorithm, fairly strong. Not really a problem so far. All right, we said that. The force does that. So that's at the top level. That's the instance level. Next, we have the database level. We have a database master key. And you do create these yourself. And it's just create master key, and whatever, password. This is secured by default by your service master key, which means when SQL Server starts up and it wants to open each database and recover it, it has to access this key, open the database, and go through its process. If the service master key cannot decrypt this key, then it can't start that database. May or may not be a problem, depends on your situation. This is a case where you may break this encryption and not allow the SMK to encrypt the database master key. If I don't want my DBAs to be accessing that database for some reason, it's got sensitive data in there, HIPAA stuff, PCI stuff, I could break this, and then when the application went to access the database, it would have to provide the password for the database master key to access the database. So there are ways to actually prevent the DBA from accessing a database in SQL Server, even a sysadmin. All right? But again, lose the key, lose the password, you ain't getting the data back. It's that simple. And this is the command. You drop encryption by service master key, essentially. So then that password protects it. So got to make sure that password is secure. Backup restore. This happens automatically. The open and close happens automatically when it's protected by the SMK. If it's not, then you have to do this. And what else? Oh, if you attach, restore, that kind of thing, you got to have that password as well. So if you go to a new server for database recovery purposes, obviously the new server, the service master key won't have the key for that database master key. Does that confuse anybody? Kind of confuses me, but you have to have the password to that. If you read this 10 times, it'll make sense. Whew. All right. Any questions? Basics? No? Yes?
What was that drop encryption by service master key? To me, that's the way we...
Yeah, so if I go back here, so I can show you, this key, when the instance starts, this key is opened by the service account. It has rights to open it. It then uses it to decrypt this key, which then opens up your sales database and allows it to access everything. I can break this link so that with that drop thing so that it can't open automatically, and that's this drop encryption by service master key. So then only the password that you've set on that database master key will open that database. All right? So you can build that in your application. You can pop up a box to the HR guy or whatever you want to do. But you can actually break that and protect those databases from the DBA. All right?
So the server will still mount the database?
You didn't raise your hand. Don't be talking without raising your hand now. Come on. All right.
So the service will still mount the database, you just can't access it?
Correct. I mean, it still have permission to the files from the Windows security side, but it can't physically read the file. All right, where were we? Here. Symmetric encryption. All right. Now this is like a normal lock here. This is my front door. You like that? You don't care.
It's a very small front door.
It's a very small front door. Yeah. I have to duck. No. The key that locks this door is the key that unlocks the door. Right? Symmetric. Same thing. Right? Essentially, the code I put in here is what's built into the tumblers. You know, that's when I lock it. That same code essentially is used to lock the thing. Weak analogy there. This one works better. But the same key is used for both sides of the encryption-decryption thing. Simple enough. These are created in a database, but you can't back them up. Seems bad, right? Well, I just told you, got to back up keys. You don't have keys, trouble, right? Well, with symmetric keys, you can actually use the same parameters and recreate the same key. So I don't need to back them up, because if I go to another database, I can recreate that same key and decrypt the data. Is that good or bad? Well, depends. You know, the answer to everything. The big thing here is these keys, while much slower than hashing, are orders of magnitude faster than asymmetric keys. Asymmetric keys are much more powerful, but they are slow. These are much easier, a lot less CPU. And so typically what we want to do is we use this type of key to encrypt our data when we want encryption. And then we protect this key with an asymmetric key. Let's look at symmetric keys. 1, 2, 3. Look at that. Every time. All right. We want symmetric keys, right? All right. So let's create a little table. We'll put a couple employees in there and their salaries, HR situation. I'm king of the world. You guys are aware of this? My kids know this. They're well aware. Dad's in charge. This job is open right now.
Yeah.
I got extra shovels at the ranch. Anybody want to come by anytime? Be happy. All right. So we don't really want to disclose our salary, though, so let's encrypt it. Let's add another column here. And all I'm doing is just adding a var binary column here. When I encrypt data, it's now not character data. It's binary data. All right. So I got to do this. I'm going to create a key. Nothing magic here. I give it an algorithm. I have multiple algorithms to choose from. Identity value, which is really just a parameter, a key source parameter, and a password. Please use a strong password. Please do not do something lazy and create some easy password. Make sure you save the password. If you don't know the password, you'll be in trouble. Actually not if you have the parameters right. But the parameters are important here because I can recreate this key. So the parameters are really, really important. All right, I have to open the key, and I'm going to encrypt the data. And all I'm going to essentially do is this function, encrypt by key, I have to pass in the GUID of my symmetric key. Now, fortunately, I have this lovely key GUID thing. Why Microsoft doesn't allow me to just pass this name and not do the GUID, I don't understand. Is anybody here from Microsoft? Good. This is stupid. All right, it's just dumb.
Tell us what you really think.
And then I passed in my salary, okay? And all I did was then I set the values in the old value to 0. So if I look at my data now, I set these to 0. This was my old salary here, and then here's the encrypted value. Now, obviously, if you were doing this application, you wouldn't have this column. You would just have this column. But you guys remember I was there. All right. I have a key GUID here, just so you can see. It's just some worthless thing. I don't know why we can't just pass in the name. Again, I didn't write it. Not my fault. They don't listen to me, obviously. To decrypt this, I decrypt it, and what do I get? Close. This is one of those things that's not really well documented. What I have to do, if I can get the keys right, I have to cast this back to some other value. I mean, here I've casted it over. I could have sent it in there, but I have to cast it back to get it back out.
So it comes back to binary.
Yeah. So if you don't cast it back, you get that kind of nonsense back. Not a big deal. You just got to remember to do it. You know, but if the developers come to you and yell at you and say it's not working, this might be the reason. All right? And it's not well documented. It's kind of an annoying thing. All right, so we didn't open the key. There's no key parameter here. Right? Why not? Anybody see something interesting about this encrypted column here? They're all the same to a point. If I scroll over, we'll see a difference out here. In this chunk right here, there's a certain amount of metadata in that encryption, which includes the key that was used to encrypt it. It's not really a security issue. It makes it a little bit easier for the decryption to occur, but it kind of stores some of the values in here to find that back, so you don't have to pass that back in. It's not really a big problem, but it's just an interesting thing, at least interesting to me. You guys might not like it. I don't know. But. All right, so my kid, whoops, let's go back. Where was I? Here. My kid is smart. My middle son is probably smarter than I am. Brilliant. Figured out that he doesn't really need to change his salary. He doesn't know what encryption is, but what he can do is copy my encrypted salary over to his. Right? Of course, God help him if Dad finds out that he did it, but he's happy, right? This job pays well. Anybody want this job now? Pays well. So what can I do about that? No decryption, we've had an attack. Same reason you worry about SQL injection with the passwords, better worry about it here too. It's a bad thing. DBA, set your salary to, the VP of something, right? Not the CEO, that's kind of a flag, but, the director or something, you wouldn't have to break encryption. Let's fix our table for a second. I'm going to add a column, a row GUID unique identifier to the end of my table, okay? I'm going to populate that, nothing major there. Let's look at my table. I dropped out the encrypted column because it doesn't matter. We'll fix that in a second. But so essentially I have here, I'm going to put encryption here, and I've got a row GUID, different for every row. So let's encrypt stuff. We're going to use the same function we did before, except this time we're going to use something else. When I encrypt, I use my GUID and my text. I have this add authenticator, 0 or 1 bit here. And then I have an authenticator, which is a sysname here. If this is a 1, then this value is used to essentially salt my encryption. Again, if this is 0, this doesn't matter, but if it's 1, I use it. I don't know why they have 2 parameters there. It's stupid thing number 2 for Microsoft today. Okay? They could just ignore this, and if this is there, use it. But again, I didn't write it. Not my fault. Nobody here's from Microsoft, or still, right? Okay. Stupid. All right. We decrypt it, get what we expect back. Okay. I know move columns around a little bit. Let's do the same attack. Now, if I do the same thing, and if you download the code and look at it and try it, what you'll find out is you can't decrypt this value anymore, or the value on this column, this encrypted value, with this row GUID authenticator. Provides you a little bit of additional protection. Now again, if that's stored into rows, you've got to be a little bit careful. You may want to still perhaps salt this with something else, plus this authenticator when you encrypt it. But provides you a little bit of a protection if you've got a row GUID that you can use somewhere to stick into your encryption algorithm. Yes, sir?
What if he copies your row GUID into his row 2?
You could do that. The whole point is you don't want, I mean, so for a developer or system administrator, somebody that is aware of the code being run, this doesn't necessarily protect, right? It's not protection against DBAs. The idea is this is protection against somebody that doesn't know what you're using as that authenticator. Because I don't have to use the row GUID in this table. I could have it somewhere else, right? I could have a lookup table of values, any number of things that I did. But if they are aware of how this is done, then that's a problem. Yes, sir?
If someone wants to snoop, what's to stop them from using the decrypt by DB key command in their queries to see what's in there?
So what's to stop them from using the decrypt? You have to be able to open this key. So I open the key at this session, in this session. And when I open the key somewhere, I have to have the password. So if in an application, I need to protect this so somebody isn't entering it. If this is an HR thing, obviously anybody who has the password can get in, but if they don't have the password, they can't snoop necessarily and do this. So that password becomes very important here. All right? There's no grant access to this key. There's no grant, revoke, deny statements. All right? These passwords are what protect these keys, really. Everybody got it? It's not that serious. I mean, unless you lose the keys. Then update your resume. That's easy enough to do, right? I got another talk on that if you want to come next week. No. All right. How am I doing on time? I'm way out of time. All right. This identity value generates the same GUID for the key. This has to be unique in a session. Just have to know that. Nothing big about it. These key source and identity, though, are used to recreate the key. So if I have those values, I can, in some other database, recreate these keys. Good for DR, good for replication, whatever I do. But it also means I need to protect those, because if somebody else has those, they can recreate it in their database. So be careful. Yes, sir?
I guess kind of the same follow-up. When you
Can I give you the same answer then? With that?
when you encrypt these, there has to be a way to unencrypt them. So why can't you just use the same method to source out all of the data?
I'm confused.
So, for example, a view or something that has the encryption or the decryption in it, why can't you use the same thing to just use that view to source out all the data?
What do you mean by source out the data?
Replicate the system, decrypt it.
Well, you could if you had a view, but I mean, if I send it to another database, I have to either have cross-database chaining to get through there. If I'm on another instance or somewhere else, then that doesn't really work, right? I mean, if I have a link server or something, it works. Okay, but the whole point is that if I move this data somewhere else, like replication, I don't want to go back to the source system. That defeats the purpose of replication, right? Okay. It's not good or bad, right? It's just the way. It's one of the ways it works, right? You can recreate these symmetric keys. All right, if that fits your need to do it. All right, you can and should secure these with asymmetric keys. That's where we get a little more protection. The algorithms in the header, we said that. You can do temporary keys. Temporary keys is kind of cool. So because I can recreate the same value, I could have this key, and symmetric keys are well known. I could create a temporary key from the application to do decryption and encryption without ever storing it in SQL Server. That's kind of cool. DBAs can't decrypt the data. Key doesn't exist in SQL Server. Only is created by the application. That's kind of good. This is encrypted. You can use encryption with passphrases as well. It's triple DES algorithm. You can't change it, but you can use a passphrase in that encrypt by instead of encrypt by key, use encrypt by passphrase. So the password then becomes important. I can have that come in from users and not ever store this in SQL Server as well. Again, DBAs can't access this data then. They don't know the password. All right, asymmetric keys. Unlike anything in the real world, they're really handy. A lot of heavy math went into actually building these and discovering this 28 years ago or something. They're based on really, really large prime numbers that work in pairs. I'm not going to go through the math lesson because I don't really know I understand it completely, but what happens is really the key that encrypts something is not the key that decrypts it. I'll show you an example in a second. These are much more secure than symmetric keys. I mean, orders and orders of magnitude more secure. But they're slow. A lot of CPU here. So as an idea, let's say here's my key 1. I take text and I run it through my algorithm and I get this. Trust me, this is this. I know because I cut and pasted it. All right? If I run this through the algorithm with key 1, I get gobbledygook back. Cannot decrypt this. All right? What I need is key 2. So if I do the same thing, and again, these are the same, through key 2 I get back. These keys are a pair. They are related. They come as pairs. The way this works is one of these keys is a private key and one's a public key. It doesn't matter which one. That's how they're referred to. When you see somebody say public key encryption, this is what they're talking about. We generate these as a pair. There's a mathematical algorithm that's used to build these. And then the whole idea here is that you want to keep one of these safe, and one of these you disclose to anybody in the world. The reason is, anybody can encrypt something with my public key. All right? But only I can decrypt it. What does that provide? That's a secure channel. Anybody has a secure channel to me. They're guaranteed that only I can decrypt that message. That's really powerful. Same two keys. If I encrypt something with my private key, anybody can decrypt it. What's that? It's authentication. It's authentication. Only I could have sent that message. Two very valuable things. How do we use these together? Well, if I encrypt something with my private key, I can then re-encrypt it with Andy's public key. Andy can decrypt it with his private key. This provides guaranteed delivery to Andy. He takes that result and he decrypts it with my public key. That proves only I sent that message. Together, I have a secure two-way channel to somebody with public-private key encryption. Anybody confused?
That's what Amazon does, right?
Is it what?
That's AWS model, public and private key.
Public and private key. You go to your browser, you do SSL encryption. This is how it works. You have the public key for various identity providers that can verify their keys. If you ever get the message, the identity of this key cannot be, verified in your browser, beware. Because that means potentially that you're not actually talking to the company you think you're talking to.
Doesn't it also mean they didn't pay the VeriSign bill?
It could mean that, but be worried.
Yeah.
Okay, you be careful because you may not have a secure channel to Amazon or Microsoft or whoever you're doing business with. All right, how do we do this inside of SQL Server? Well, we can do this. We have DDL. All these things have full DDL support, so create, drop, alter, all that stuff. We also have utilities. Because this is well-known public stuff, the whole idea behind really strong encryption in the world is that the algorithm does not matter. What matters are the passwords that secure those things. So in this case, these algorithms are public. We have two utilities, one from the Visual Studio SDK and one from Windows SDK, that will allow you to create public-private key pairs. Okay? You can then import these into SQL Server or create them in SQL Server. Either way, they do the same thing. They're all asymmetric keys. A certificate is essentially the same as an asymmetric key as well, just with some metadata added to it. Here's essentially just what we do when we want to do encryption is we create a key, an asymmetric key, a symmetric key, we encrypt our data, we open the parent key, the child key, and decrypt our data. That's essentially what you're trying to do. Okay. All this stuff I've already showed you. There's nothing magic here. I'll show you the protection here, and that's why it says demo. So ready? Everybody ready? 1. I don't know why it's 3 times. It just is. I don't know. All right, so let's find the asymmetric key thingy. Come to the top. Let's make sure we don't have a key because that would be ugly if we did. So I'm going to create a key, asymmetric key. Boom. Ta-da. Nobody's impressed. All right, that's fine. I'm not impressed either. No password here. I didn't do it. It doesn't matter because what I'm really doing is I'm protecting these pairs of keys here. So I got to keep one private, one public. So I have these keys. I can encrypt data directly, which is fine if I want to. There's full support of these functions. This is just really slow. Any volume of data, this is orders of magnitude slower than symmetric keys. So typically you don't want to do this. You can if you really want. Decrypt it. To decrypt it, hello, oops, oh, sorry. Sorry. The thing's out of order. I need this value, sorry. Here. Semicolon. Helps you declare variables. What? Oh. Sorry. I figure where it was. Decrypts it back. Trust me. Because the way I'm doing this, I have to get the value back. I can't just use the value there because I've got these two key things there. It'll make sense if you play with this a little bit. I'm running out of time. I can create a certificate here. There's a make cert. Here's the command that comes there. If I go to, I ran this before. What this does, this is the representation of what happens in SQL Server, is I get a certificate file, which is my public key, and a private file, which is my private key. This is essentially what SQL Server does when you create these asymmetric keys. I can back these up, and I'll have these copies. I'm showing certificates, because certificates are a little bit more common in terms of files we'll see here, but you could do asymmetric keys here as well. These are asymmetric keys that have metadata with them. Here I can just do a create, and I can do these files here. I've already done that. I can just create one inside the server. This is exactly the same as the asymmetric key, but I've got some of this extra metadata here inside SQL Server, and these just allow us to do more with SQL Server. Pat's taking pictures, so I can back them up. I'm just going to go a little bit faster here because I'm trying to get this done. If I were to drop this certificate, I would recreate it from the files like this. If I wanted the exact same certificate back, I wouldn't do a restore. I just create it from the file. Okay, I can do that with asymmetric keys as well. Here's where the encryption would take place. When I create a symmetric key, instead of doing that password, encryption by password, I would do encryption by certificate here and give it the certificate or encryption by key and have the key here. This would provide me the protection that I would have, okay, because this would protect that relatively weak symmetric key with my asymmetric key. And I can do the password stuff in here too. I'm not going to go through this because I'm out of time, but essentially I'm doing a similar demo here with the names and passwords, but with the two keys for the encryption. It works exactly the same. It's not really exciting to see the same results occur, but I've opened the key there. Let me just go back here. Sorry, my apologies, we were late. You can use this password. Again, that's where your protection is with that password, because somebody would need that password to open the asymmetric key, which would then automatically open the symmetric key if the encryption link was there. That provides you a good balance. Here's the interesting thing. I can remove the private key from my database. I can drop that private key. Why would I do that? Anybody? Anybody? All right, we're out of time. Fine. Imagine I'm an e-commerce site on Amazon.com. I'm taking your credit cards and I'm processing stuff. I can take your credit card and I can store it encrypted on my system. And if I drop that private key and a hacker gets through the Amazon web application into my database, he has no way to decrypt that data. I can log ship that data or replicate it somewhere else to some other database where I've got a copy of the private key, no access from the public side. I can do the decryption there and submit it to the bank for processing and everything else. It's a really valuable feature if I can remove this private key. Data cannot be decrypted from that database. All right. Certificates are asymmetric keys with metadata. SQL Server does not check the expiration date in your certificate. Why? Well, if you forget to renew your certificate and it expires, that's really bad. So the metadata in the certificate about the expiration date is for your edification only. It does not provide any kind of enforcement. So if it expires, it's up to you to go buy a new certificate, decrypt everything, re-encrypt it with a new certificate, et cetera.
So
All right?
Steve, there's no CA involved then in any of this?
No, there's no CA involved. You can use the CA if you would like. There's no certificate of authority involved in this. Certificate of authority would be Thought, eTrust, any of these companies that will sell you a certificate. In this, it doesn't matter because you're not trying to do a hierarchy of protection. You're just encrypting certain data, so it's not important here. But I'll talk about that in just a second. We have larger certificates in SQL Server. So communications, real quick, since we're out of time. You can do two options for encrypting the communications link between the client and server. You can use SSL encryption, which uses certificates. You can use IPsec. If you're really nice to your Windows administrator, they'll set up IPsec. Use IPsec, right? Because A, you don't have to do it, and B, it's better. Okay. But if you want to do SSL, you can do SSL. Use long keys if you're going to do the mechanism for enabling this. There's a procedure in books online. It's like 12 steps. There's nothing magic. You just follow the 12 steps. If you use certificates to do SSL communication, do not create your own. That's where you need a CA. Because if you create your own, somebody can just replace that with their own certificate, and there's no check. If you use a real certificate from CA or something, anybody that connects with a browser or something else will verify that that is a real certificate from CA or from Thought or from whoever, and they'll get a message that says it didn't work, and Sebastian's going to be mad at me. So in terms of communication, when you go out to the public, when you don't have control of everything, you've got to have a certificate from a real company. And it's linked to your particular host name, your FQDN for your server and stuff. So, key length, please use long keys when you do this. This is recently, 384-bit key, public key, can be cracked on this laptop. Now, this is a great laptop. It's a MacBook Air. It's really good, but it can be cracked. 512-bit key can be cracked on Amazon for about $75. Spin up a bunch of VMs, brute force attack. All right. 768 could be cracked by Microsoft, IBM, government of Iran. All right, they have the resources to do that kind of stuff. Please go 1024 or further at this point in time if you are using public keys, because it puts it effectively out of practical reach for most companies. That may change any point in time. Think about 2048. Think about 4096. All right. There's the thing there. That's it. I got to go because Sebastian's mad at me. Thank you for coming. Hopefully you enjoyed it. If you got questions, I'll be in the hallway. All right.